Hello everyone. Thank you for taking the time to watch this presentation about my chosen topic, the gambler's fallacy. This heuristic stood out to me for various reasons, with the main one being that I actually enjoy gambling. However, enjoying gambling and being good at it are two very different things. Sometimes the gambler's fallacy has been a factor in my poor play. But before I get too deep into the presentation, I feel like I should start by defining some pretty important terms. The first of which is heuristic. A heuristic is any technique or approach that helps to solve a problem. They allow people to solve problems and make judgments quickly and efficiently. But they are also prone to errors. These errors are known as cognitive biases. A cognitive bias is an error in thinking that occurs when people are processing and interpreting information. They are often a result of our attempt to simplify the way we process information. The next term is representativeness heuristic. Yes, that is a mouthful. This heuristic is psychological and is used when making judgments about the probability of an event under uncertainty. An example of this would be meeting someone with long hair and a laid-back attitude and making the assumption that they are from California simply because you have seen or met someone from California that has these traits. Finally, let's define the gambler's fallacy. The gambler's fallacy is a cognitive bias that is produced by the representativeness heuristic and states that people evaluate the probability of a certain event by assessing how similar it is to events that they have experienced before. I have found myself guilty of employing the gambler's fallacy when making various decisions, especially when gambling. Sometimes it has worked out for me, but most of the time it has proved to be an incorrect way to approach a decision. But let's get more specific about the gambler's fallacy and some examples of it that will help you understand it a bit better. I'm going to give two non-IS examples and two IS examples. The most commonly used example is playing the game of roulette. I'm sure most of you already know this, but in roulette, the dealer pushes a ball into a spinning wheel of numbers that are on red and black pockets. The players wager on which number and or color the ball is going to land on. Most casinos keep track of the results and display them on a scoreboard for players to see and use to make decisions about what they will bet on. Let's pretend that the ball has landed on black 10 times in a row. What color would you bet on for the next spin? Red, right? This is an example of the gambler's fallacy. Just because the ball has landed on black 10 times in a row does not mean that the odds for landing on red on the next spin are going to change. The most famous example occurred at the Monte Carlo Casino in 1913. The ball fell on black 26 times in a row. A bunch of people lost a ton of money because of the gambler's fallacy that night. Another non-IS example is playing scratch-off tickets. Yet again, I'm likely detailing something already known, but scratch-off tickets, which can be bought at various convenience stores, are cards that require you to scratch away an opaque covering in order to win prizes. They can be very addicting. You may not win on the first couple, but odds are you have to eventually get a winner, right? You just have to keep buying them until you get that big winner. Yet again, the gambler's fallacy has caused us to make a poor decision. Now let's get into some examples that relate to information systems. After doing all of my research for this topic, I did not find any clear commonly used examples that deal with IS. That scenario is not as simple as betting on black after a streak of red, or continuing to use a set of lottery numbers with the expectation that they will eventually hit. Therefore, I decided to share the intent of my presentation with and interview some members of the software development and infrastructure teams at InSpark to get some real-world examples of the gambler's fallacy in an IS environment. The first example that we discussed dealt with ignoring important practices simply because they have not occurred yet. There are some developers that prefer to operate in their own local development environment and do not regularly check in their code or get the latest code from other developers. There is a false belief by this specific developer that since they have always been able to code this way with no issues, they will be able to continue operating this way. There have been many instances at InSpark where integration issues occur, and developers are required to backtrack through the code to locate the source of this issue. Communication among developers is very important during the software development lifecycle. Best practices should be followed instead of the good fortune that developers have had in the past. Another example that we discussed dealt with allocating resources for server creation. As new projects are introduced and development begins, servers will need to be created for various environments. For example, there will need to be an application server and a database server created for quality assurance testing, a set of those for user acceptance testing, a set for production, and so forth. Most of the time, the infrastructure team uses the experience from previous projects to determine the amount of resources, such as RAM, disk space, etc., to set aside for these servers. The initial allocation is almost never right. They will either need to be increased to meet demand or decreased to avoid wasting resources. While these resources can be easily adjusted when necessary, the gambler's fallacy can occur when using this method of guesstimation to make purchasing decisions for the fiscal year. Let's say that the infrastructure team guesses that they will need to service 5 new projects in 2016 and will need to purchase new equipment to do so. They will calculate the average number of servers used for each project in 2015 and the amount of RAM and disk space used by each. By using previous projects as the measuring stick, the infrastructure team takes a gamble that they will have enough resources to successfully service the needs for each new project while also maintaining the current ones. Some kinks can be thrown into this plan by new and emerging technologies. For example, the development team at InSpark decided to implement Docker and microservices into a new project this year. The problem is that the infrastructure team had prepared for these technologies to arrive in 2016. Due to the nature of the technologies, the amount of resources required to develop, test, and publish the project's resulting application grew significantly. This caused the infrastructure team to scramble and get some new equipment installed and working to meet the increased demands. Going back to the topic of gambling, I found an interesting article when researching for this presentation. In 2014, an article was published in Cognition that detailed a study done by University College London professor Nigel Harvey and graduate student Yuman Yu. They used real-life online gamblers from a betting website as subjects to test the gambler's fallacy. What they discovered was that most of the online gamblers were very aware of the fallacy and were actually employing the opposite of the gambler's fallacy, which is dubbed the hot hand fallacy. This is belief that a person who has experienced success with a random event has a greater chance of further success in additional attempts. I'm sure you've heard the phrase, "I've got the hot hand," or "I'm hot right now," if you have done any gambling. I know I have definitely used the phrases before myself. But in all actuality, both of the fallacies create a false belief that a previous result has any effect on what will happen next. Another interesting article that I found regarding the gambler's fallacy is a story posted on NPR in 2013 about deciphering hidden biases during interviews. This is actually very relevant to students looking for employment after school. The story, voiced by Steve Inskeep and Shankar Vedantam, details various scenarios that could occur during the interview process that could affect a person's chance of making a positive or negative impression. One example mentioned was that most candidates would prefer to be interviewed after a weak candidate in order to look stronger. However, a study involving 9,000 interviewees conducted over 10 years determined that going after a strong candidate did not hurt the interviewee. What really mattered was going last on the day of interviews. The interviewers seemed to employ the gambler's fallacy. If it had been a good day with many good candidates, it was not in the interviewee's best interest to go last. But if it had been a weekday with many weak candidates, going last could be beneficial for the candidate. Well, I feel like I've rambled enough about the gambler's fallacy, and hopefully this topic is a bit more clear to you now. This bias, or heuristic, is very real, and I believe that it occurs more often in our lives than we would believe. If you would like to see the gambler's fallacy in action, here's a fun social experiment that you can try. My friends and I like to play a card game that we call Ride the Bus. It is also known as Around the World, Up the River, Down the River, and it has many other names. But anyways, there are 2 rounds. During the first round, players are dealt cards one at a time. For the first card, players must guess the color of the card, red or black. For the second card, players must guess if the card will be higher or lower than the first card. For the third card, players must guess if the card will be outside or in between the first 2 cards. For the fourth card, players must guess which suit the card will be. This is normally played as a drinking game, so incorrect guesses are penalized with drinks. And the second round is very reliant on the drinking concept, so I won't go into detail about that here. It can easily be Googled if you need the remaining rules. But if you play this game or decide to give it a try with some friends, pay attention to the guesses during the first round. Players like to try and analyze what cards have been dealt to determine what is next. For example, if 3 players in a row have gotten 3 red cards in a row, then the next player will likely choose black to try and avoid the consequences. Well, I hope this presentation helped you to better understand the gambler's fallacy, and thanks again for your time.